Alright, algebra students, in this video we're going to cover imaginary numbers. Now, imaginary numbers were basically created to be able to help solve equations that previously we didn't know how to solve them. When you have the square root of a negative number, we've always been taught, well, you can't do that. Well, imaginary numbers help us to do that, and they help us to do a lot of other things too later on in math. But the big thing that you really need to write down, now you don't need to write down all this stuff probably, but the big thing that you need to write down is that the square root of a negative 1 is basically I. Okay? The pure imaginary number, what I would write down, pure imaginary number is written in the form where it is b times I. That b is a real number, so like 4I. And the I is the imaginary part. Okay? Now, to simplify a negative square root, if it's like a negative 4, well, you can split that up so that it's negative 1 times 4. We can break down that 4, or whatever the number may be, if it's not a perfect square. Now, 4 is. And then we can simplify the radical, but basically taking out the negative on the outside and making that an I on the outside if it's negative on the inside of the square root. Okay? If you need to, pause the video, but I'm going to move on to some examples and I'll show you exactly what I'm talking about. Okay, so we've got a few examples, and I'm going to zoom in here just so I can focus on number 1, but we've got the square root of negative 9. So if I were to take this and I break this up into where it is the square root of negative 1 times the square root of 9, hold on a second, times 9, sorry, that's exactly what negative 9 is, right? Well, I can take that negative 1 out now, and it becomes I times the square root of 9. I can also do the square root of 9, and that is 3, so your answer becomes 3I. So really, and I didn't need that many steps, but I'm trying to show you. Really, it's the same thing as doing square root stuff. The only difference would be if it's a negative, you're going to have an I out there as well. Okay, number 2 is radical 5. Now, we can't take the square root of 5. I know that, okay? But we can take out the I. So I would come out, and then you're still left with the 5 on the inside of the house, and that's it, okay? Because you can't break down 5. And that's all you can do. But you can take out the negative, and when you take out the negative, that brings out an I. All right? Number 3, you got 32. Now, 32, I believe, is one of those things that you can actually break down. So let's try this out. So we're going to take out the I, and I'm going to bring out, and I'm going to make it radical 32. And now it's a regular old problem. The only difference is we've got that crazy I that's out there. So I'm going to do our t-chart. So that'd be 2 times 16 and 2 times 8 and 2 times 4, 2 times 2 and 2 times 1. Group off some things together, and it looks like this would be, there's 2, 4. We multiply that, and then with a radical 2 left on the inside. So that 4 goes on the outside, and that radical 2 goes back inside. Again, I multiply this 2 times this 2, not add. That's your final answer. Okay? Let me go back. I'm lock these in. Oh, there we go. All right. So now let's try another one. A little bit more complicated. I did this one just because I think it would make it a little bit longer of a process. But we're going to take out the I first, okay? And then you got 192. And now same old, same old. So that is 2 times 96, which is 2 times 48. Which is 2 times 24, 2 times 12, 2 times 6, 2 times 3, and 3 times 1. Okay, now let's see what groupings we got. Looks like we got 3 groups of 2. That makes that 2 times 2 times 2. That'd be an 8. We've still got that I that we took out at the beginning, and then a radical 3. And that's your final answer. Okay? And that's how you break down negative square roots. It's just an I that's there. Okay, it helps a lot of upper level math things take place. Okay, let's try some other stuff. Okay, remember when we're solving with square roots, it's really, you're going to try to get the x squared by itself, and then you're going to take the square root of both sides. So for instance, on number 5 that we have here, we would subtract 81 from both sides. Well, today's lesson is all about negative square root stuff. So you got you got negative 81, and then when you take the square root of both sides, you end up getting x is equal to the square root of negative 81. Okay, so again, could pose a problem, but we know better than that. Now we can take the negative out now. Okay, and then we can take the square root of 81. Well, the square root of 81 is 9. So I forgot about my pluses and minuses, but we're solving equations now, so that's important. So the square root of 81 would be 9, but it was a negative 81, so it'd be 9i. Okay, so plus or minus 9i. All right, let's try another one. We do need pluses and minuses again. Okay, we'll subtract 15 from both sides. And so you get 4x squared is equal to the negative 24. Then if you divide both sides by 4, you get x squared is equal to a negative 6. Okay? Then, so you can't take the square root of a negative 6. But we can at least try to break down the radical. I don't think the 6 will break down, but what we can do is we can call it x is equal to plus or minus. We've got that I that we can take out, and then just radical 6. If it won't break down, then just leave it like that. Okay? Let's try another one. Last one on this type of equations, but it's the same as solving a regular old equation. If you have a negative, we're just going to take an I out. So we're going to add 5, start off with that, add 5 to both sides. You get 3x squared, and then you get a negative 441. Okay? Then we're going to divide both sides by 3, so x squared is equal to, it's still going to be a negative, and it's going to be a negative 147. Okay, now to clear out that x squared, we're going to take the square root of both sides, and we've got a negative inside our radical. So x would be equal to, we're going to need to try to break down this 147, see if that'll actually go. Let's try that out. We'll do our t-chart. We'll have an I out there, but 2 won't go into 147. But 3 will go 49 times, and then 3 won't go into 49. I know that that's 7 times 7, and then we can go 7 times 1. So it's a pair of 7s. We had that negative there. I didn't pull out the I at the beginning. I had been doing that. But it would be plus or minus 7i, and then with the 3 inside the house. And that's it. Okay? We got a few more things. It'd be nice if we could stop there, but we can't. Okay. We are going to talk about how to deal with certain powers of I. Okay, and that's what I wanted to do on this page. First off, we know that we're going to start with the one that we know. That's I to the first power. Well, I to the first power is just the square root of negative 1. And we've simplified that before. I'm going to leave a little bit of a space because some of these we're going to write out a little bit more. That is just I. Okay, makes sense. I to the first power is just I. Okay, I did put that square root of negative 1 in there just to kind of go back over that. We'll use it again here in a second. All right, now, what if I squared it? I to the second power. Well, that's square root of negative 1 times the square root of negative 1, right? Well, if I were to square something, or actually you could actually show it maybe a little bit better if you did like this. If I were to square a square root, then that takes away the square root symbol and everything, and you end up just getting negative 1. So if I were to square I, you get negative 1. Think about that. Doesn't that make sense? Okay. If I were to take it to the third power, let's try it to the third power and see what happens. if I were to take I to the third power, well, what happens is that's the same thing as I squared, which we just did, and then times another I, right? And so really what you have is this I squared, that's negative 1. So it's negative 1 times I, which is going to give us a negative I. So that output would be a negative I. Okay, the third power would be a negative I. And then lastly, actually probably not lastly, we're going to do a few more, but I to the fourth power. Well, I to the fourth power is really like taking I squared, right, and squaring it. Well, we know that I squared is negative 1, right? Well, negative 1, if I take it and I square it, what do you get? You get positive 1. Okay? So I to the first power is I. I squared is negative 1. I to the third power is a negative I. I to the fourth power is 1. Let's continue that pattern on. Let's see if I got enough room down here. I think I do. So I to the fifth power. I to the fifth power. Well, what that is, that's really like saying it's I to the fourth with another I tacked on, right? Well, we know that I to the fourth, we just did it, was 1, and you got 1 times I. Well, that's just going to be I. Okay, let's try another one. I to the sixth. I to the sixth is the same thing as I to the fourth times I squared. All right? Well, we know that I to the fourth is 1. We know that I squared is a negative 1. And if we multiply those two together, you get negative 1. So I to the sixth would be negative 1. Okay? Let's try I to the seventh. Hopefully, you might be seeing a pattern here. You get this would be I to the fourth, and then with an I to the third. Well, we know that I to the third, we did that one up above. We got it at negative I, so it's 1 times a negative I. 1 times a negative I, or 1 times anything, is just going to be that anything. So that would be negative I. Okay? And then lastly, just to kind of round out the pattern, you should see there's a pattern going on here. I to the fourth is, I to the eighth is I to the fourth times I to the fourth. Well, what that is, okay, that'd be 1 times 1. Well, 1 times 1 is just 1. And you see here, if I back up just a little bit, you see we've got a pattern. We have I, negative 1, negative I, 1. I, negative 1, negative I, 1. And there's a pattern, and that pattern continues to go on forever and ever and ever. Okay? And so that is what we need to look at when we're looking at powers of I. Okay? Hopefully this little demonstration makes sense. Okay? Because we're able to then extrapolate that and do a lot more stuff. But it does get a little bit tricky. Let's try some out. Okay, so now we're actually going to try to figure out what it would be if we took it to the 15th power. Now, you could write 15 down. That wouldn't be too terribly bad, but look at number 9. You're writing down 62 of them. Well, that would be horrible. Okay, so what I would suggest is let's find a different way. Now, there are different strategies on how to do this. You could kind of try to figure out where you are in the pattern of 4. Like I know that if I had I to the 16th, then that would complete my pattern of 4. And then I know that 15 would be just one before that. So then you would be up at negative I. Because at that fourth thing, every fourth thing, you go back down to your pattern repeats. So the fourth thing in the pattern would be 1. And then after that, you go back down to I, negative 1, negative I. Here's what I would suggest, okay? And I'm going to do it a little bit differently. I know Lehrman, I think, teaches this a little bit differently. But what I would do is I would treat this and divide 15 by 2, okay, and make this I squared. And if you divided it by 2, it goes 7 times evenly, okay? but we still have 1 left over, so there's still 1 I out there. If you think about this, it checks out. If I have a parentheses like this, I multiply, so 2 times 7 is 14, and then I've got my 1 scraggler. Okay, so it's 2 times 7, that's 14, but then you got the other one over there to make 15. So that checks out. Okay, and then you can do I squared. Now I squared is -1. -1 to the 7th power. And you still got your I. Okay, and we've simplified it already. You can probably know -1 to the 7th power, anything to the, if it's a negative number to an odd exponent, then it's going to be negative. So it's -1, and then it's times your I, which ends up being -I. Okay, so again, those are 2 different ways you could think about it. You could think about this as though, okay, well, I know at 16 I would be at 1 because 16 is divisible by 4. 15 is not, but it's really close to it. It's right there, right before 16. And so my next number in my pattern before 1 would be -I. But I like this way because it takes some of the thinking out of it. Okay, and some of the number sense that you need to know. Okay, I to the 62. Well, if we did the same thing, this would be I squared. Okay, and then that would be 31. Okay, we know I squared is -1, so you end up getting -1 to the 31st power. Okay, well, again, anytime a -1 is raised to an odd exponent, it's still going to be odd, and so it's just -1. That's it, your answer. Okay, if you thought about it the other way, you try to think about how many times will 4 go into 62. Well, it'll go 15.5 times, which means that you've gone halfway through your pattern. Well, halfway through your pattern would put you at like the I squared mark, and that'd be a -1. Okay? So, again, 2 different ways on thinking about that. We'll practice that more as we go along, but hopefully that makes sense. I like dividing by 2. I think that makes more sense to me. Okay? And then we'll do one more thing. Okay. Now, the last thing we're going to do is we're going to do products of imaginary numbers. So we're just going to multiply these 2 things together. So 4 times 7, that's 28. And then you've got I times I, which would end up being I squared. 28I squared. Well, I squared is -1. And -1 times 28 would end up being in -28. So when you have an I and you multiply it times an I squared, that goes back to that pattern thing we talked about. And that'd be a -1. Okay? Let's try another one. Remember when you have exponents, remember you're going to distribute. So we're going to distribute the 3 on the inside here, and that makes it 2 to the 3rd power and then I to the 3rd power. Okay, and we're still going to eventually multiply this times 5I. All right, so, but this would be 8I to the 3rd times 5I. Then if you multiply those 2 together, you get 40I to the 4th. Okay, so it's important to know where you would be at in that pattern, I to the 4th. Well, I to the 4th would just be 1. So it's 40 times 1, which ends up being just 40. Okay, so the i's went away, and they do sometimes, especially when you have multiple of them, because when you have I to the 4th power, then it completely goes away, and it doesn't even leave a negative. And then the last thing that I wanted to do would be a negative radical, a radical where the radicand is negative times another one. Okay, so -18 times a -10. What you have to do first, I know you probably want to multiply 18 and 10, and -18 and -10, and that'd be positive, and that'd be beautiful. But you can't do that. You got to take out the i's first. Okay, so this would be I radical 18 times I radical 10. And then from there, then you can multiply. So I times I is I squared, and then you've got 18 times 10, which would be 180. And then just depending upon how you want to break it down, you can do your T-chart or whatever it is that you want to do. 180 is 2 times 90. 90 is 2 times 45. That'd be 3 times 15, and 3 times 5. And then 5 times 1. So you got your groupings, okay? So your answer, therefore, it would be, so if you took out your numbers, you're multiplying here, so that'd be 6 I squared, and you got the radical 5. Now, I squared, again, we can do I squared. That would be a negative 1. So it's really 6 times negative 1 with that radical 5. And that'd be a negative 6 radical 5. Final answer. Didn't need to show all those steps, but I am just to try to show you what it is we're doing. But you got to take the i's out first on those. And that's it. Long story short, I mean, I know the pattern can be confusing, and figuring out what the exponents and stuff can be confusing, but the rest of this stuff, I think is very doable. When we have a negative inside that radical, then we take out an I. It's an imaginary number, and it makes a lot of math make a lot more sense the further you go on up. Okay? If you have any questions, let me know, and hopefully I'll see you tomorrow.